Okay, hi everybody. I'm going to show you real quick how to add auto bed leveling to your Wilson TS 3D printer. The machine that I'm going to work on today is here in front of me, obviously, and this one has the E3D hot end, and it has this larger fan duct that I use with those. But the modifications that we're going to make will work with either this setup or with the original fan duct for the Wilson design that uses that's meant for the J head. The E3D fan duct actually sticks out a lot further, so this is what I designed the parts to. And the design is meant to attach to the side of the extruder, and I'm going to reuse the two screws that hold the hot end on so that we don't have to add any unnecessary extra hardware. And I've got all the parts here that we'll need. There's two printed parts. So this one holds the end stop. That's going to be our new Z-axis end stop, and then this mounts to the servo motor, which goes into this other piece, which will mount to the side of the extruder. So the servo that I'm using is just a standard hobby servo you've probably seen all over the place, and all I've done to add to this is I added wires. So I spliced a longer wire onto this, so it still terminates in this 3-pin connector, but it has about 70 centimeters of wire, which is what you're going to need to get from all the way from the hot end over the frame and back to the electronics. Then this is going to be our new Z-axis end stop, so this is what will mount to the servo, and it also has the longer wires attached. So it's the same type of switch that was originally on the machine, just longer wires, same connector. And then I also have a short piece of PET flexible sleeving. So this is just a cosmetic thing, sorta. It makes it so you can get the wires bundled together, makes it all cleaner, but it also does prevent the wires from getting tangled up and getting problems like that. And then I have a couple zip ties. This little piece comes with your servo, so you're going to need that, as well as this little screw should have also come with the servo. And then we will need 3 M2 by 16 millimeter screws and 3 M2 nuts. So after we get this put on here, then I'll show you the changes that you need to make to your firmware in order to actually get all this to work. So first things first is to mount your end stop switch to the end of this arm, and there's a slot here on the end that you just line up with the little holes and put 2 M2 screws through there, and then these 2 vertical slots on the sides are for putting a zip tie through there in order to secure those wires so that they don't have any, they're not pulling against the switch. Okay, here's what that should look like when you're done. It's pretty simple. And now get this small plastic piece that came with the servo, and just pop the pointy end of that down into this slot that's on the front side of the mounting arm, and then press it in. So that's all there is to that. And then go ahead and mount that to the servo. So holding the servo so that the wires are up, I'm going to mount this right on the end so that the arm points down, and then you use this little screw that came with the servo right in through here just to hold it on so that it can't wiggle off. Just like that. And now mount that to this piece by thread the wires just for the servo through this hole in the servo mount, and then slides in like that. So now the servo arm should be kind of tucked in into this receiver slot, and the top of the servo should line up with this one little hole. And so now we'll put a M2 by 16 millimeter screw right through there with the nut on the back. Okay, so here's what it should look like when it's all built. So there's that screw in there, and then you can use another zip tie here to kind of loop the servo motor wires forward and then back through there, and then give the wires for the in-stop switch a little extra room so that they can move around, but then zip tie them down right to that point, and now they'll be nicely strain relieved. So now we just have to mount this to the extruder, and this is pretty easy too. Let's move around here so we can get a better look. So what we have to do is take the two M3 30 millimeter screws out that hold the hot end in place. Just take those completely out. And then on the other side, on this side of the extruder, are the two nuts that those were screwed into. Should be pulled into these little recesses, and what we need to do is get them out of there. So what I do is just unthread, just get one of these M3 screws and screw it in a little bit from this side. And then just work it out like that. Okay, so now we have both of our M3 nuts back. Now we can put the hot end clamp back into place. Try not to knock your hot end out. Okay, now you should have both of the screws back in place here, and just put those two nuts just on the ends. Thread them on so there's, you know, 1/4 of an inch or so between the nut and the body of the extruder. And then these two slots that are on our servo mount should just slide right over those screws. And so what we're trying to do is we want the nut obviously on this side. Should just slide right down like that. And then when we tighten the screws down, it's going to pull those nuts against the body of the servo mount, and it'll all lock into place. And you can check that it got them in properly. By now this should be nice and tight, so see, it's not going anywhere. So that's the mounting part, that's the easy part. Now I'm going to put this I'm going to go ahead and put the sleeving over these two pairs of wires now, and then I'll probably secure that with a couple more zip ties, and then I'll show you how to connect it to the ramps board. Okay, so I've turned the machine around so that we can see the ramps board, and I'll show you where to make the connections that we need. Now the first thing is that the servo connections are over here, and the servo power is actually via a jumper that's down here, and that's not normally installed. So if you don't have it, like this one doesn't, you gotta get a 2-pin jumper and put it on the right 2 pins of this little 3-pin connector. So right there. And then the servo motor is going to connect up here. So here I've got those. And there's connections on ramps for 4 servos. So the first one is on the bottom here. It's these 3 pins. And the red pin on this connector maps back to the orange pin on my servo, because the wires on this weren't, when I spliced them on, weren't the same colors. So the orange one, which is the signal, the positioning indicator, should go on the left. The middle one actually goes to the 5-volt connection of the servo, which is usually red, and then the one on the right would be the dark, maybe brown or black connection on the servo, which is ground. So plug that in, put that jumper on, and then up here you should have a connection already for the Z in stop. You want to pull that off, that's for the existing one, and then we'll get our new Z in stop that's on our probe and plug it in the same spot. So that's on the second row of in stops, which is the 3rd pin down on this block of pins. Okay. So now that we've got that, we can make our changes to our firmware. So I'll show you that next. Okay, now we're back and we've got our computer hooked up over USB to our printer. The printer's turned on, and I've loaded the Arduino IDE and the Marlin firmware. And what we're looking at is the configuration.h file, and I'm going to show you the changes to make in there. So the first one is pretty far down, 400 or 500 lines. You'll find this this line right here, define enable auto bed leveling. So it's commented out by default, so I commented it in, or removed the comment. And then a little bit below that there's some more settings. I'll explain what these are later, but you need to set these values here. Left position 15, right position 140, front 20, and back 150. Then going down a little bit farther, there's these 3 values here that need to be changed from the default. So the X offset from the extruder is -54, the Y is -7, and the Z is -7. And what those are is that's the distance in millimeters from the tip of our hot end to the location of the probe. So for the E3D hot end, this last one, the Z offset, is -7. If you're using the J head, it's a shorter hot end, so that number has to be larger. So you start with a value of -18 if you're using the J head. And then a little bit further below there, this Z raise before homing, we should actually have that set to the same number probably as up there. That's the amount it'll raise up, because we can't extend the probe down, obviously, if the arm can't, if we're so close to the bed that the arm can't extend. And then I've changed some settings here for the speed. The speed is in millimeters per minute, so I just put 100 times 60, so I get 100 millimeters a second. And then Z, raise before probing, raise between probing, raise after probing. I have all those set to 5 millimeters. Now page down a little farther. Actually a lot farther. Around line 770, at least on this version of Marlin. You'll find this row. Define num servos. So it's commented out by default, so remove the comment so that that's included. And then right below that is servo in stops. So remove the comment and it should be -1, -1, 0. So we're not using servos for X and Y, that's why they're -1. And then the line right after that is our in-stop angles. So start with, you can start with any values I guess, because you're probably going to have to change them, but you can start with these if you'd like. I have the extend angle set to 80 and the retract angle set to 170. So since we're not sure what the position of our servo was when we put the arm on the servo, and we're not real confident in those values, so we're going to review how to get those dialed in. And that is all of those changes. So then just compile that and flash the Arduino, and then when the machine resets, what you should see is the probe should flip up out of the way, because that's the retract position. So normally it's retracted when we're not using it. So if the machine resets and it flips up, that's a good sign. If it doesn't move at all, it's not necessarily a bad sign, but it might not be hooked up correctly, or it might not have power, or something else could be wrong. But after you have that flashed into the machine, you'll need to start. I'm going to run Pronterface is the way that when I need to communicate to the machine directly, I use this. And you might use something else, but anything that'll let you send G-code commands directly to the machine. So the first thing you want to do is figure out what are the correct angles for our probe. And you can set the setting for the servo directly. To do that, you need to issue an M280 command. So type M280 followed by the servo number. So it starts at 0, so capital P number 0. And I'll zoom in so you have some hope of reading this. And then S followed by the angle that you want. So let's say we wanted to go to 180 degrees. Now when I hit enter, oh, I forgot to connect. Alright, so connect, and now I'll send that command. Alright, so our probe only moved a little, and that's because my retract angle was already 170 degrees. So retracted, you want the probe sticking out forward like that. I'm going to just change the setting on the command here. I'm going to subtract 90 degrees. I'm going to say S90. So there it went down. You can see how it's not quite pointing straight down. So you have to kind of play with the value a little bit. Now I'll try S80, and that looks just about right. So if you were to look at that close up here, you'd see that that's the lever arm, or the base of our in-stop is parallel to the bed. So when you figure out what that value is, write that down, and then if you add 90 degrees to that, so that was 80, so I'll add 90, so that's a S170. It should flip up 90 degrees and it'll be safely out of the way. So when you have those two values, close Pronterface, or disconnect, go back to the Arduino IDE and change those two values. Change the two, the extend and retract. First number is extend, second number is retract. So change those and then reflash the machine again to get the final values in. Then you can go back here, and after you reconnect to the machine, so down here now we're going to type G28. Oops. G28. And when we issue that command, that's going to tell the machine to home all three axes. So now you see what it did was when it got to the Z-axis homing, it moved the extruder out to the middle of the table, extended the servo arm, and then it just lowered down until that switch got hit. So that's what should happen in that case. Now if we wanted to test the angles again a little easier, another thing you can do is issue an M401, and that should lower it down. M402 will raise everything up by the amount that we told it to do before probing, and then it'll pull the arm back out of the way. Now if we issue, let's do an M28, I mean a G28 again. Now at this point, because it's homed everything, the tip of the extruder is actually the distance above the bed that we told it our probe is. So for instance, if you looked at your display up here at the top of the printer, it says Z is 7 right now. So back on the pronter face, if we typed a G1 Z0 down in this box, and then we hit enter. Now it'll lower the extruder down to what it believes is the 0 position, and if you look under here real carefully, the tip of the extruder nozzle should just be right at the print bed. So if it's not, then you need to tweak that that last number in the firmware. So that was back up here. The Z probe offset from extruder. So if it's too close to the bed, then that number needs to be larger. If it's too far from the bed, like it doesn't go all the way to 0, when 0 isn't touching, then it needs to be a smaller number. Now you might have to actually adjust that number from time to time, or a couple times until it's really good. But the good news is you can also do that from the smart LCD controller now with the latest version of Marlin, so that really helps out. Now if we want to actually run the auto bed leveling, we would go back here to pronter face, and we will issue, we need to start with a home, so it's always a good idea to home first. So G28, and now G29 will do the bed level. So the bed level algorithm is going to go probe several points. Alright, so now once that's been run, back here, if you're issuing this command directly, you'll see it will spit out some numbers to tell you the matrix that it calculated for the actual bed, but you don't need to know any of that. The real magic that happens now is that the firmware has those numbers committed into RAM, and anytime we issue or a print file issues a move command, it will automatically adjust for that notion of where the bed actually is located, that whole plane. And so that's it in a nutshell. After this, all you have to do is in your whatever the slicer is that you're using, there should be a section where you can tell it custom G code that you want to have inserted before the print job. So that usually includes things like the G28 command to do a home, the preheat levels. You need to add that G29 to that. So find wherever it does a G28, and right after that line add a G29. And if you don't see a G28, then just add one in there. And that should be it, and then it should just do this wonderful bed leveling algorithm before every print, and you will be perfectly level all the time. Alright, well, I think that's everything you need to know. I'm going to attach a little cheat sheet of the G-code commands that I used after this video so that you can see them all in one place. And if you have any questions, just shoot me a message, and have fun. Bye.